We are at electric power system, aircraft system at RISE. We have working on the project long-term price scenarios of frequency regulation services. To identify future challenges regarding the security of supply, imbalance between supply and demand, and system frequency, we need to do some long-term market analysis for preparing to increase the flexibility of future in the grid by providing like environment and support new technologies enter to the market, such as the batteries or demand response or hydrogen and vehicle-to-grid technologies. So we want to have a long-term scenario analysis to provide a vision toward their future revenue and their support, their decision-making, and also investment and operation. The main objective of the project is to increase the knowledge about these frequency reserves in the future and develop the methods to estimate the impact of frequency regulation services for the future, considering the interaction between balancing service providers or actors and reserve market. The interaction refers to the entering these new technologies to the market and evaluating the effect of both the penetration of the new entrants in the market and also the overall market outcome. And also, based on the method that we developed, we forecast the price time series for each market for the scenarios that can be used as a tool for estimating the impact of these BSPs in the market, such as hydrogen and battery and vehicle-to-grid technology. So at RISE, we are the main responsible and coordinator of the project, but we are sharing our result and progress with the partner of the project. And we wanted this figure shows an example of FCRN market, historical data for 7 years from 2017 and 2023. And we don't see any trend in the year or between the years, so we don't expect any similar trends. So we wanted to see that how difficult, like, it's not easy to quantify these values for different markets. So based on this, we want to forecast different market prices. And we are using two methods, one agent-based model and one machine learning model. The agent-based model is used to consider this interaction between actors. In agent-based model, why do we need agent-based model? Is because we need to capture the strategic behavior, dynamic of the market, and also the competition effect. So agent-based model gives output to us. The output is day ahead, the spot market prices for the future, and then it is the input of our machine learning model to predict future ancillary service prices. So in this way, we thought that we can consider this interaction between the agents and the reserve market. This is an overview of our agent-based model. We have real bids data for spot market for Nordic in 2019. In each hour, we have a lot more than 1,000 bids, but we aggregated them to 11 agents. So the trained agents create the new bids for us in the training function in our model. Here we see the prices for 11 agents for 2 p.m. in 5th February 2019. And here we see the validation of the volume generated by the train agent in comparison with the orange color is historical and blue is our train agent volume. And then we clear the market based on marginal pricing. And we see the validation of the day ahead price for January 2019, which has a high accuracy with the blue color is the forecast and with historical data that we have for day ahead market price. So we have the connection between the agent-based model. We give these day-ahead prices to our machine learning model, and we use other parameters such as hydropower production or other historical FCRN price, for example, and then we generate our ancillary service prices in machine learning model using a rolling time window, which is 28 days. And for example, in here we have the validation of machine learning model. In blue color, it is observed, the historical and predicted. In the orange, that we predict here for 28 days based on 3 months historical data. So here we wanted to show just that we have much using the error calculation, the error score in some time period is less, around 10, but in some period it is higher. But if we look at the longer time period, we see that the error score is not that much significant. For example, in average, we have 10, which is not significant in comparison with if we look at only one time period, which is higher. So this figure is just for 4 months, which is longer, and each dot here is the average error of 28 days. And we have 2 curves because we have 2 error methods, mean absolute error and root mean square error. But the point is that only just we wanted to see that in longer time period we have a high, how to say, accuracy. So we are happy with this result, with validation. Thank you for listening.
Thank you very much, Elnaz. That's a very good start. Before you go down, I will soon ask Per to come up. Can you just say something about how do you do this project? Are you working on it alone, or do you work with some colleagues? And where do you get the data from?
Yeah, we are at RISE. We are 4 people. 3 of us is from electric power aircraft system, and 1 is from energy system unit. And 2 of us are working on agent-based model, 2 of us are working on machine learning model. In the beginning, it was a little challenging in terms of data, because we are not given any data from Swisscom CraftNet, but we have had the Nordic day-ahead bit data, and that's why we decided first we model the forecasted day-ahead prices using agent-based model, and then use this, which already is considering this interaction, and give it to machine learning to forecast the ancillary service price. But if we had the bid for example, FCRN or ancillary service, then we could apply them also in the agent-based model to get more accurate forecast for these prices.
Okay, great, thanks. So a little bit of a shout out to get more data. Can it be helpful? Yeah. Thank you very much. Another applause from Elnaz.